Linear approximation. The equation of the line in red, that's why we call it L of x, comes from the slope formula. As you can see, if you move this to the left, it's like y2 minus y1. And this is a slope, and this is x2 minus x1. Just if you wonder why it looks like this. That's this line right here. The whole idea behind the linear approximation is the following. When you have an equation, which is in blue, of a function f of x, to evaluate some values close to a, and it might be sometimes hard to evaluate, so we kind of like walk on the red line and take it from there. As you could see, close to a, we could steal it from the red line. That's called linear approximation. Now notice this is a curve and this is a straight line. Our function is a curve and it's approximated to a straight line with a slope. That is, of course, when you are close to a, this a. Let's get started. Verify the given linear approximation. We need to verify this at a equals 0. Now, of course, if a is 7 or anything else away from 0, that's not going to be close to this line. You saw the graph. It's going to be a different line. So that is given or approximated to this straight line when you are close to a equals 0, when x equals 0. That's another way to say it. Then use a graphing calculator. Now we're not going to use algebra steps. We're going to have to use a graphing calculator or any graphing application to determine the values of x. This is a different type of problem now, besides verifying this or finding the linear approximation, for which the linear approximation, this guy here, is accurate within 0.1. So the error margin is 0.1. Round your answer to 3 decimal places and enter your answer using interval notation. If you have seen some videos for me, the way I do it, I take my time typing the problem with colors, and I do prepare the slides ahead of time to save you some time from watching videos or lengthy videos. So my idea is, if I could make a video that covers the problem or the material, instead of 15 minutes, less than half, maybe 7 minutes or less, that's my goal. So let's keep going. You'll notice what I mean by having notes clear. Linear approximation. We saw the graph on the first slide, so we're gonna approximate f of x that was given to us using L of x when we are close to a. But what is linear approximation in general before we attempt the problem? We use the tangent line. This is the tangent line, as you could see, at the point a f of a as an approximation to the curve, which is in blue, when x is near a. An equation of this tangent line is y equals f of a plus f prime of a, the first derivative of the function, which is a slope, when you plug in a, slope of the tangent, times x minus a. The linear function whose graph is this tangent line, that is L of x. Now we call it L of x because we do have a curve and we have a line to distinguish between the two y's, if you notice the notes has it both y's. To distinguish between both functions, the blue and the red, let's call the red one L for a line. So L of x instead of y equals f of a plus f prime of a times x minus a. That's called linearization of the blue line f at a. Of course, we'll have to stay next to a to use that line as an approximation. The approximation becomes, in short, as a concept, what we're doing. We're saying that f of x, which is in blue, will be approximate to values coming from L of x, which is the tangent line, when we are close to a. So we have to be close to a, as you could see from the graph, to use this approximation. Or, now I'm writing f of x in blue. I'm saying that the function itself, the curve, is approximate to L of x. Because L of x is in red, I could replace that with f of a plus f prime of a times x minus a. This is called the linear approximation of the function f, the blue one, at a. So that's the whole idea of linear approximation. Let's go back to the problem. Here's the problem. It says verify, so we need to verify that this is equal or approximate to this. In other words, this is the function f of x when we are close to a equals 0. The equation of the tangent line, which we called L of x earlier, is going to end up with a y-intercept of 1 and a slope of -12. Then we have to use some graphing method like Desmos or a graphing calculator to determine the values of x for which the linear approximation is accurate to within 0.1. In other words, what they're trying to say here is how far could you go away from a equals 0 to use this approximation and stay within an error of 0.1, not more. That's the whole idea. Now, we know that f of x equals 1 plus 4x to the power -3. If you remember from the first slides, and which is written right here. That's my f of x. F prime of x, because we need it for the linear approximation formula, or the equation of the tangent line, we need the derivative to find the slope and so on. Here's f prime. We bring the -3 up front, so the exponent, we reduce it by 1, becomes -3 minus 1, which is -4, times 4, because of the chain rule. 4 inside, or 4x, its derivative is 4, so instead of putting it at the end, I have it right here. That's called chain rule. Okay, now let's go back to the formula in short, which is f of x equals or approximate to L of x. And we know what's L of x in general. It's f of a plus f prime at a times x minus a. But what is a? A is 0. So let's put zeros right here. So we have f of x is approximate to f of 0. Notice the left side is the curve, and the right side is L of x, or the equation of the tangent line. So we have f, we're going to plug in 0 in it to find f of 0. We have f prime, we're going to plug in 0 in it and find f prime of 0. As simple as that. Using the first line, f of x equal f of 0, plug in 0 right here. I have 4 times 0, which is 0, 1 to the power -3, or 1 over 1 to the power +3 is just 1. Let's plug in 0 in the derivative. Let's plug in 0 in the derivative. So we have f prime of 0 equals the following: negative 12. The inside part becomes 1 plus 0, which is just 1. And outside, negative 3 times 4, that's negative 12. Let's go back to the left, down below, and fill them in. So f of 0 is 1. F prime of 0 is negative 12. This is a 1. That's right here. And this is negative 12. So we have 1 plus negative 12 multiplied by x minus 0, or in other words, multiplied by x. So check. We've done the word verify. We're done. We're not completely done with the problem. We need the second part, which is coming right here. Now we need to say that the line or the values on the line compared to the values on the curve to be less than 0.1. So I'm going to use the absolute value. 1 minus 12x, that's the values of the line L of x, and that's the values of f(x) itself. The difference between them, how far they are apart, I want it to be less than 0.1. Hopefully that's clear. Now we know that from pre-calculus and from college algebra how to solve absolute value less than something. So it has to go like less than that number and greater than the opposite, which is negative. That's part of the absolute value properties. No absolute value, as you could see, so I have the difference less than 0.1 and greater than negative 0.1. We're going to add this to all three sides. That's an approach, one way to do it. And I have the following. So this is the curve shifted up 1 unit, 0.1. And this is the curve shifted down 0.1. And this line lives in between. Hopefully that's clear. So graphically, this is what I have. This right-hand side is this right here. And this left-hand side is the purple color right here. And 1 minus 12x is the blue line in between them. But here's the idea to solve it graphically. See these 2 points? That says that 1 minus 12x is above, greater than, reading it backwards, than the graph that was shifted down, which is in purple. This will be true when x, that's x1 and that's x2. Let me go back and write it one more time. This is x1 and this is x2. So when we are between x1 and x2, so how to find those x1 and x2, that's on the coming slide. The values will end up, that's x1 and x2, negative 0.029 and 0.036. As interval notation is written, I don't have to read it. And here we go. I'm zoomed in to those points. As you could see, that satisfies the inequality that we have, or the compound inequality, because it has 2 parts. I graphed, as you could see on the left, the function that was shifted up, the function that was shifted down, and the line, which is 1 minus 12x. You know which one is which because of the colors. And I clicked on this point and clicked on label it. Okay? Actually, this point is down here. And I clicked on this point and I asked to label it. As you could see, clicked on the label mark right there. So to have this equation of the line right here, this line, to be above this curve, the one that was shifted down 0.1. That will be true when you are between this x and this x, written as typed, rounded to 3 digits. That's negative 0.029, which is right here, and that's 0.036, rounded to 3 digits. Or as an interpretation option. That's a very handy software to use, as you could see. So it tells you which one is which, and you could click on the points and ask to label it, so you could see actually when it's labeled, it tells you the values of it. And that should do it.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.